Learning objectives.
At the end of this topic, you will be able to understand the method of finding areas of similar triangles, describe Pythagoras Theorem and converse of Pythagoras Theorem, evaluate given problems based on Pythagoras Theorem and converse of Pythagoras Theorem. Introduction. We've learned that in two similar triangles, the ratio of the corresponding sides is the same. Now let's establish a relationship between the ratio of the areas and the ratio of the corresponding sides. We are given two triangles ABC and PQR, such that triangle ABC is similar to triangle PQR. We need to prove that area of ABC by area of PQR is equal to AB by PQ whole square is equal to BC by QR whole square is equal to CA by RP the whole square. For finding the areas of the two triangles, we draw altitudes AM and PN of the triangles. Let us take an example to illustrate the use of this theorem. In the figure, the line segment XY is parallel to side AC of triangle ABC, and it divides the triangle into two parts of equal areas. Find the ratio AX by AB. We are already familiar with the Pythagoras theorem from earlier classes. Now we shall prove this theorem using the concept of similarity of triangles. In proving this, we shall make use of a result related to similarity of two triangles formed by the perpendicular to the hypotenuse from the opposite vertex of the right triangle. The previous discussions lead to this theorem. Perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse. Then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. Let us now apply this theorem in proving the Pythagoras theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Proof. We are given a right triangle ABC, right-angled at B. We need to prove AC square is equal to AB square plus BC square. Let us draw BD perpendicular to AC. Baudian theorem. Note, the theorem discussed was earlier given by an ancient Indian mathematician, Baudian, about 800 BC in the following form. The diagonal of a rectangle produces by itself the same area as produced by its both sides, that is, length and breadth. For this reason, this theorem is sometimes also referred to as the Baudian theorem. We shall now prove the converse of the Pythagoras theorem in the form of a theorem. In a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite the first side is a right angle. Proof. We are given a triangle ABC, in which AC square is equal to AB square plus BC square. We need to prove that angle B is equal to 90 degrees. To start with, we construct triangle PQR, right-angled at Q, such that PQ is equal to AB and QR is equal to BC. Now from triangle PQR we have Example 1. Find the ratio of the area of two similar triangles if one pair of their corresponding sides are 4 cm and 6 cm. Let the two triangles be ABC and PQR. Let BC be equal to 4 cm and QR be equal to 6 cm. Area of ABC by area of PQR is equal to BC square by QR square. That's equal to 4 square by 6 square. That's equal to 16 by 36. Let's move to another example. In a right triangle, the sides containing the right angle are of length 6 cm and 8 cm. Find the length of the hypotenuse. Example 3. Find the length of the diagonal of a rectangle, the lengths of whose sides are 6 centimeters and 8 centimeters. In the figure is a rectangle PQRS. Join the diagonal QR. Now QRS is a right triangle. Therefore, QS square is equal to SR square plus QR square. That's equal to 6 square plus 8 square. That's equal to 36 plus 64. That's equal to 100. QS is equal to 10. That is, the length of the diagonal of rectangle PQRS is 10 centimeters. Summary. Let's summarize the topic. The ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding sides. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. In a triangle, if a square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle.